ಇದು ಮಾಹಿತಿ ಖಜಾನೆ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿ.
ಮಾಹಿತಿ ಖಜಾನೆ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿಗೆ ನನ್ನೆಲ್ಲ ಸಂಯುಕ್ತರಿಗೂ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತ. ಇಂದು ನಾವು ಮತ್ತೊಂದು ಉಪಯುಕ್ತ ಮಾಹಿತಿಯೊಂದಿಗೆ ಬಂದಿದ್ದೇವೆ. ಈ ವಿಡಿಯೋ ನಿಮಗೇನಾದರೂ ಇಷ್ಟವಾದಲ್ಲಿ ಲೈಕ್, ಶೇರ್, ಕಾಮೆಂಟ್ ಮಾಡಿ ಹಾಗೂ ಇನ್ನು ಹೆಚ್ಚು ಉಪಯುಕ್ತ ಮಾಹಿತಿಯನ್ನು ನಮ್ಮ ಯೂಟ್ಯೂಬ್ ವಾಹಿನಿಯಿಂದ ಏನಾದರೂ ನಿರೀಕ್ಷಿಸುತ್ತಿದ್ದೀರಾ? ನಿರೀಕ್ಷಿಸಿದಲ್ಲಿ ಬೆಲ್ ಐಕಾನ್ ಅನ್ನು ಕ್ಲಿಕ್ ಮಾಡುವುದರ ಮೂಲಕ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿ.
Introduction to mobile computing. The rapidly expanding technology of cellular communication, wireless LANs, and satellite services will make information accessible anywhere and at any time. Regardless of size, most mobile computers will be equipped with a wireless connection to the fixed part of the network, and perhaps to other mobile computers. The resulting computing environment, which is often referred to as mobile or nomadic computing, no longer requires users to maintain a fixed and universally known position in the network and enables almost unrestricted mobility. Mobility and portability will create an entire new class of applications, and possibly new massive markets combining personal computing and consumer electronics. Mobile computing is an umbrella term used to describe technologies that enable people to access network services anyplace, anytime, and anywhere. A communication device can exhibit any one of the following characteristics: fixed and wired. This configuration describes the typical desktop computer in an office. Neither weight nor power consumption of the devices allow for mobile usage. The devices use fixed networks for performance reasons. Mobile and wired. Many of today's laptops fall into this category. Users carry the laptop from one hotel to the next, reconnecting to the company's network via the telephone network and a modem. Fixed and wireless. This mode is used for installing networks, e.g., in historical buildings to avoid damage by installing wires, or at trade shows to ensure fast network setup. Mobile and wireless. This is the most interesting case. No cable restricts the user, who can roam between different wireless networks. Most technologies discussed in this book deal with this type of device and the networks supporting them. Today's most successful example for this category is GSM, with more than 800 million users. 1. Applications of mobile computing in many fields of work. The ability to keep on the move is vital in order to utilize time efficiently. The importance of mobile computers has been highlighted in many fields, of which a few are described below. A. Vehicles, music, news, road conditions, weather reports, and other broadcast information are received via digital audio broadcasting (DAB) with 1.5 megabits per second. For personal communication, a universal mobile telecommunications system (UMTS) phone might be available, offering voice and data connectivity with 384 kbps. The current position of the car is determined via the Global Positioning System, GPS. Cars driving in the same area build a local ad hoc network for the fast exchange of information in emergency situations, or to help each other keep a safe distance. In case of an accident, not only will the airbag be triggered, but the police and ambulance service will be informed via an emergency call to a service provider. Buses, trucks, and trains are already transmitting maintenance and logistic information to their home base, which helps to improve organization, fleet management, and saves time and money. B. Emergencies. An ambulance with a high-quality wireless connection to a hospital can carry vital information about injured persons to the hospital from the scene of the accident. All the necessary steps for this particular type of accident can be prepared, and specialists can be consulted for an early diagnosis. Wireless networks are the only means of communication in the case of natural disasters, such as hurricanes or earthquakes. In the worst cases, only decentralized, wireless ad hoc networks survive. C. Business. Managers can use mobile computers, say, critical presentations to major customers. They can access the latest market share information. At a small recess, they can revise the presentation to take advantage of this information. They can communicate with the office about possible new offers and call meetings for discussing response to the new proposals. Therefore, mobile computers can leverage competitive advantages. A traveling salesman today needs instant access to the company's database to ensure that files on his or her laptop reflect the current situation, to enable the company to keep track of all activities of their traveling employees, to keep databases consistent, etc. With wireless access, the laptop can be turned into a true mobile office, but efficient and powerful synchronization mechanisms are needed to ensure data consistency. 2. D. Credit card verification. At point of sale, POS, terminals in shops and supermarkets, when customers use credit cards for transactions, the intercommunication required between the bank central computer and the POS terminal, in order to effect verification of the card usage, can take place quickly and securely over cellular channels using a mobile computer unit. This can speed up the transaction process and relieve congestion at the POS terminals. E. Replacement of wired networks. Wireless networks can also be used to replace wired networks, e.g., remote sensors, for trade shows, or in historic buildings. Due to economic reasons, it is often impossible to wire remote sensors for weather forecasts, earthquake detection, or to provide environmental information. Wireless connections, e.g., via satellite, can help in this situation. Other examples for wireless networks are computers, sensors, or information displays in historical buildings, where excess cabling may destroy valuable walls or floors. F. Infotainment. Wireless networks can provide up-to-date information at any appropriate location. The travel guide might tell you something about the history of a building, knowing via GPS, contact to a local base station, or triangulation, where you are, downloading information about a concert in the building at the same evening via a local wireless network. Another growing field of wireless network applications lies in entertainment and games to enable, e.g., ad hoc gaming networks, as soon as people meet to play together. Limitations of mobile computing: resource constraints, battery interference, radio transmission cannot be protected against interference using shielding and result in higher loss rates for transmitted data, or higher bit error rates respectively. Bandwidth. Although they are continuously increasing, transmission rates are still very low for wireless devices compared to desktop systems. Researchers look for more efficient communication protocols with low overhead. Dynamic changes in communication environment, variations in signal power within a region, thus link delays and connection losses, network issues, discovery of the connection service to destination, and connection stability interoperability issues. The varying protocol standards. 3. Security constraints. Not only can portable devices be stolen more easily, but the radio interface is also prone to the dangers of eavesdropping. Wireless access must always include encryption, authentication, and other security mechanisms that must be efficient and simple to use. A simplified reference model. The figure shows the protocol stack implemented in the system according to the reference model. End systems, such as the PDA and computer in the example, need a full protocol stack comprising the application layer, transport layer, network layer, data link layer, and physical layer. Applications on the end systems communicate with each other using the lower layer services. Intermediate systems, such as the interworking unit, do not necessarily need all of the layers. Application transport network, network, data link, physical radio medium, a simplified reference model. Medium black circle, physical layer. This is the lowest layer in a communication system, and is responsible for the conversion of a stream of bits into signals that can be transmitted on the sender side. The physical layer of the receiver then transforms the signals back into a bit stream. For wireless communication, the physical layer is responsible for frequency selection, generation of the carrier frequency, signal detection, although heavy interference may disturb the signal, modulation of data onto a carrier frequency, and depending on the transmission scheme, encryption. Medium black circle data link layer. The main tasks of this layer include accessing the medium, multiplexing of different data streams, correction of transmission errors, and synchronization, i.e., detection of a data frame. Altogether, the data link layer is responsible for a reliable point-to-point connection between two devices, or a point-to-multipoint connection between one sender and several receivers. Medium black circle network layer. This third layer is responsible for routing packets through a network or establishing a connection between two entities over many other intermediate systems. Important functions are addressing, routing, device location, and handover between different networks. Transport layer. This layer is used in the reference model to establish an end-to-end connection application layer. Finally, the applications, complemented by additional layers that can support applications, are situated on top of all transmission-oriented layers. Functions are service location, support for multimedia applications, adaptive applications that can handle the large variations in transmission characteristics, and wireless access to the World Wide Web using a portable device. GSM, mobile services, system architecture, radio interface, protocols, localization and calling, handover, security, and new data services. GSM services. GSM is the most successful digital mobile telecommunication system in the world today. It is used by over 800 million people in more than 190 countries. GSM permits the integration of different voice and data services and the interworking with existing networks. Services make a network interesting for customers. GSM has defined three different categories of services: bearer, tele and supplementary services. Bearer services. GSM specifies different mechanisms for data transmission, the original GSM allowing for data rates of up to 9600 bits for non-voice services. Bearer services permit transparent and non-transparent, synchronous or asynchronous data transmission. Transparent bearer services only use the functions of the physical layer, layer 1, to transmit data. Data transmission has a constant delay and throughput if no transmission errors occur. Transmission quality can be improved with the use of forward error correction, FEC, which codes redundancy into the data stream and helps to reconstruct the original data in case of transmission errors. Transparent bearer services do not try to recover lost data in case of, for example, shadowing or interruptions due to handover. Non-transparent bearer services use protocols of layers 2 and 3 to implement error correction and flow control. These services use the transparent bearer services, adding a radio link protocol, RLP. This protocol comprises mechanisms of high-level data link control, HDLC, and special selective reject mechanisms to trigger retransmission of erroneous data. 5. Using transparent and non-transparent services, GSM specifies several bearer services for interworking with PSTN, ISDN, and packet-switched public data networks, PSPDN, like X25, which is available worldwide. Data transmission can be full duplex, synchronous with data rates of 1, 2, 2, 4, 4, 8, and 9. 6 kbit s or full duplex, asynchronous from 300 to 9, 600 bit s, tele services. GSM mainly focuses on voice-oriented tele services. These comprise encrypted voice transmission, message services, and basic data communication with terminals as known from the PSTN or ISDN, e.g., fax. The primary goal of GSM was the provision of high-quality digital voice transmission. Special codecs, coder or decoder, are used for voice transmission, while other codecs are used for the transmission of analog data for communication with traditional computer modems used in, e.g., fax machines. Another service offered by GSM is the emergency number, for example 911, 999. This service is mandatory for all providers and free of charge. This connection also has the highest priority, possibly preempting other connections, and will automatically be set up with the closest emergency center. A useful service for very simple message transfer is the short message service, SMS, which offers transmission of messages of up to 160 characters. Sending and receiving of SMS is possible during data or voice transmission. It can be used for serious applications such as displaying road conditions, email headers, or stock quotes, but it can also transfer logos, ringtones, horoscopes, and love letters. The successor of SMS, the Enhanced Message Service, EMS, offers a larger message size, formatted text, and the transmission of animated pictures, small images, and ringtones in a standardized way. But with MMS, EMS was hardly used. MMS offers the transmission of larger pictures, GIF, JPG, WBMP, short video clips, etc., and comes with mobile phones that integrate small cameras. Another non-voice tele-service is Group 3 Fax, which is available worldwide. In this service, fax data is transmitted as digital data over the analog telephone network according to the ITU-T standards T4 and T30 using modems. Supplementary services. In addition to tele and bearer services, GSM providers can offer supplementary services. These services offer various enhancements for the standard telephony service, and may vary from provider to provider. Typical services are user identification, call redirection, or forwarding of ongoing calls, barring of incoming and outgoing calls, advice of charge, AOC, etc. Standard ISDN features such as closed user groups and multi-party communication may be available. GSM architecture. A GSM system consists of three subsystems: the radio subsystem, RSS, the network and switching subsystem, NSS, and the operation subsystem, OSS. RSSU. Radio cell BSS, MS, MS radio cell MS BTS, BSC, BSC Master of Science, NSS VLR, HLR, OSS, EIR, AUC, OMC BTS, Master of Science VLR Signaling ISDN, PSTN, GMSC PDN WF Functional architecture of a GSM system network switching subsystem. The NSS is responsible for performing call processing and subscriber-related functions. The switching system includes the following functional units: Home Location Register, HLR. It is a database used for storage and management of subscriptions. HLR stores permanent data about subscribers, including a subscriber's service profile, location information, and activity status. When an individual buys a subscription from the PC's provider, he or she is registered in the HLR of that operator. Visitor Location Register, VLR. It is a database that contains temporary information about subscribers that is needed by the Master of Science in order to service visiting subscribers. VLR is always integrated with the Master of Science. When a MS roams into a new Master of Science area, the VLR connected to that Master of Science will request data about the mobile station from the HLR. Later, if the mobile station needs to make a call, VLR will be having all the information needed for call setup. Authentication Center, AUC. A unit called the AUC provides authentication and encryption parameters that verify the user's identity and ensure the confidentiality of each call. Equipment Identity Register, EIR. It is a database that contains information about the identity of mobile equipment that prevents calls from stolen, unauthorized, or defective mobile stations. Mobile Switching Center, Master of Science. The Master of Science performs the telephony switching functions of the system. It controls calls to and from other telephone and data systems. Radio Subsystem, RSS. The radio subsystem, RSS, comprises all radio-specific entities, i.e., the mobile stations, MS, and the base station subsystem, BSS. The figure shows the connection between the RSS and the NSS via the A interface, solid lines, and the connection to the OSS via the O interface, dashed lines. Base Station Subsystem, BSS. A GSM network comprises many BSSs, each controlled by a base station controller, BSC. The BSS performs all functions necessary to maintain radio connections to an MS, coding and decoding of voice, and rate adaptation to from the wireless network part. Besides a BSC, the BSS contains several BTSS, base station controllers. BSC The BSC provides all the control functions and physical links between the Master of Science and BTS. It is a high-capacity switch that provides functions such as handover, cell configuration data, and control of radio frequency (RF) power levels in BTS. A number of BSCs are served by and Master of Science. Base Transceiver Station, BTS The BTS handles the radio interface to the mobile_station. A BTS can form a radio cell or, using sectorized antennas, several and is connected to MS via the interface, and to the BSC via the ABUS interface. The interface contains all the mechanisms necessary for wireless transmission, TDMA, FDMA etc. The BTS is the radio equipment, transceivers and antennas, needed to service each cell in the network. A group of BTSs are controlled by an BSC. Operation and Support System. The Operations and Maintenance Center, OMC, is connected to all equipment in the switching system and to the BSC. Implementation of OMC is called Operation and Support System, OSS. The OSS is the functional entity from which the network operator monitors and controls the system. The purpose of OSS is to offer the customer cost-effective support for centralized, regional and local operational and maintenance activities that are required for a GSM network. OSS provides a network overview and allows engineers to monitor, diagnose and troubleshoot every aspect of the GSM network. 8. The mobile station, MS, consists of the mobile equipment, the terminal, and a smart card called the Subscriber Identity Module, SIM. The SIM provides personal mobility, so that the user can have access to subscribed services irrespective of a specific terminal. By inserting the SIM card into another GSM terminal, the user is able to receive calls at that terminal, make calls from that terminal, and receive other subscribed services. The mobile equipment is uniquely identified by the International Mobile Equipment Identity, IMEI. The SIM card contains the International Mobile Subscriber Identity, IMSI, used to identify the subscriber to the system, a secret key for authentication, and other information. The IMEI and the IMSI are independent, thereby allowing personal mobility. The SIM card may be protected against unauthorized use by a password or personal identity number. Radio interface. The most interesting interface in a GSM system is the radio interface, as it comprises various multiplexing and media access mechanisms. GSM implements SDMA using cells with BTS and assigns an MS to a BTS. GSM, TDMA, at FDMA frequency 935 to 960 MHz, 124 channels, 200, downlink 800 to 915 MHz, 124 channels, 200 kHz, higher GSM frame structures time GSM TDMA frame 2. 3 4 6 7 4 615 milliseconds GSM time slot, normal burst, guard space tall user data 5 training S 3 bits 57 bits 126 bits 1 user data space 57 bits minus 546 5 us 577 us GSM TDMA frame, slots and bursts.